Hello, calculus fans. All right, let's try to integrate integral from 0 to pi over 4 of cosine squared x dx. So a couple of things are different here. First, the obvious thing, which is that this is a definite integral, so we're going to have to plug those values in at the end. But the other big one is that we don't have a spare sine or cosine to pull out. So remember, when we did this before, anytime we had an odd power of sine or cosine, we were able to save one of them and convert the remainder into the other trig function. Here, we don't have that. So anytime you're faced with an integrand that has an even number of sines and an even number of cosines, you're a little bit stuck. We're going to have to do something different. Okay, there is a double angle formula. And it looks like this. Cosine 2x is equal to cosine squared x minus sine squared x. Now let's modify this a little bit. Let's take the cosine squared x and turn it into 1 minus sine squared x, which then turns into 1 minus 2 sine squared x. Now, what happens if we solve for sine squared x? Well, go ahead and try it, see what you get. What you'll end up getting is a half angle formula. You're going to get sine squared x is equal to 1 minus cosine 2x all over 2. So that's taking the fact that cosine 2x is equal to 1 minus sine squared x and solving for sine squared x. Okay, so let's remember this half angle formula. We're going to need it later on. Now let's take our double angle formula and manipulate it a different way. What I want to do is come up with a different half angle formula. So let's take cosine 2x, which is equal to cosine squared x minus sine squared x, and let's change the sine squared x into 1 minus cosine squared x. You notice that I'm just making liberal use of the Pythagorean identity, which says that sine squared x plus cosine squared x is equal to 1. If we clean this up, we'll get 2 cosine squared x minus 1. Now, try it again. Take this expression, the fact that cosine 2x is equal to 2 cosine squared x minus 1. Take the expression that you get on the right-hand side, solve for cosine squared x, and see what you get. Go ahead and take a moment to try that out. What you're going to end up with is this other half angle formula. Cosine squared x is equal to 1 plus cosine 2x over 2. Now, did you pause the video and work this out? This is exactly what you should be doing. As you're watching these videos, this is not a passive thing. Get in there with some pencil and paper and work things out. Pause the video, work things out, then come back to the video. Now we're going to use these half angle formulas a lot to simplify trig integrals. Whenever you have something where you don't have an odd power of sine and cosine, you're going to have to employ these. They're definitely worth memorizing. All right, let's go back now to the integral that we had in the original problem, the integral from 0 to pi over 4 of cosine squared x dx. So what we'll do is we replace the cosine squared x dx with 1 plus cosine 2x over 2. This is using our half angle formula. All right, I'll just pull the 1/2 out. And now I'm ready to compute an antiderivative. Now you'll notice that this portion of it, in order to do an antiderivative, you might have to make a substitution for 2x. You know, if you've done enough of these, you should start to see where this is going to go. In fact, I'm just going to go ahead and write down an antiderivative. So, an antiderivative of 1 plus cosine 2x would be x plus 1/2 sine of 2x. Okay, if we plug in the 0 and the pi over 4, this is what we're going to end up with. You might want to work that out and make sure that that's exactly what we get. So notice, we computed an antiderivative of cosine 2x without using a substitution. Okay, so going from here to here, I think that's something you should definitely be able to start doing without specifically making the substitution. It's kind of as if you're making a substitution in your head. Okay, that's all for now.